This will be a short presentation demonstrating the TicTacToe method for interpreting blood gas results. Our first row at the very top is going to be our pH. A normal pH is anywhere from 7.35 to 7.45. The second row is going to be carbon dioxide, a molecule produced by the respiratory system. Normal ranges are anywhere from 35 to 45. When higher than 45, that indicates a state of acidosis. Less than 35 indicates a state of alkalosis. Bicarbonate is a molecule representative of metabolic abnormalities or normalcy, and the ranges are from 22 to 26. Less than 22 might indicate a state of acidosis, and higher than 26 are associated with a state of alkalosis. When using the TicTacToe method, we're looking for results to fall by majority in one column versus another to determine the status of our patient. And in this case, everything is normal, which is ideal, but the following cases are not going to be this easy. Let's see how this TicTacToe method works with our first blood gas result. First, we have a pH of 7.33, which would fall in the acidosis column at the upper left-hand corner. Next is a carbon dioxide of 60. This would also fall in the acidosis column because it's higher than 45. And last, we have a bicarbonate of 24, which falls in the normal range. To determine the state our patient is in, we're going to look for common results falling in one column. In this case, we have carbon dioxide and our pH falling in the acidosis column. Carbon dioxide indicates that we have a respiratory etiology. If it were to fall in the bicarb section, that's going to be more of a metabolic process. So in this case, we have an uncompensated respiratory acidosis. Let's try this again. Our pH is 7.33, falling in the acidosis column of the pH area. Our CO2 is normal, falling in that center column. And last is the bicarbonate of 17, which is going to be less than 22, placing it on the left-hand side under the acidosis column. We have both our pH and our bicarb in the acidosis column, indicating that we have an uncompensated metabolic acidosis. This patient's pH is 7.53, falling in the right-hand column under alkalosis. Next is the carbon dioxide of 20. This is going to fall also in the right-hand column under the alkalosis because it's less than 35. And last is our bicarb of 23. This is a normal range, therefore down the center column. Here we have common results on the right-hand side with our pH and our carbon dioxide, indicating that we have an uncompensated respiratory alkalosis. All right, just when you think this is easy peasy, I have a challenging one for you here. We have a blood gas of 7.39, which is categorically normal. You'll notice that I'm pushing it slightly to the left-hand side of this normal column up here. Next, we have a carbon dioxide of 60. This is going to be abnormal, falling in the acidosis column. We also have a bicarb of 40, which is abnormal, but it falls in the alkalosis column. So this is a little confusing, right? We have two abnormal values, and we have a normal pH. What this means is that we have compensation that's occurred. the body has done something to make it have a state of normal pH. And this is where placing that pH value slightly to the left is going to be helpful. So because it's leaning towards an acidosis state, I can categorically kind of push it over to that left-hand side under the acidosis column and say that I have a compensated respiratory acidosis. Here's another one for you. We have a pH of 7.43. I'm going to put that up in my normal column, but it's leaning slightly to the right near my alkalotic column. My carbon dioxide is 49, indicating a state of acidosis, and the bicarb is 29, leaning towards my alkalosis column. So how do I handle this? Well, my pH is normal, so that indicates that I have compensation that's occurred. And because it's leaning more towards that alkalosis column, I'm going to consider it being an alkalotic type pH and say this is a compensated metabolic alkalosis. We hope this presentation has helped you find an easier way to analyze blood gas results. Thank you for taking the time to watch this presentation.